Welcome to the Explainer. You ever wonder how your favorite websites load like instantly? Well, today we're going to pull back the curtain on caching. It's this invisible engine that makes the whole modern web feel so fast.
All right, so here's the game plan. We're going to start with why we even need caching in the first place. Then we'll dive into all the different layers it operates on. And finally, and this is the juicy part, we'll tackle the big, tricky problems that caching creates. And of course, how engineers get around them.
Okay, so to really get why caching is such a big deal, we first need to understand the problem it's trying to solve. The villain of the story. And it all boils down to this one fundamental question. How do you build an app that can actually grow? I'm talking from just a handful of users to millions.
So let's imagine for a second you're building an app, and you decide to put everything, I mean the code, the database, all of it, on one single machine. Sure, it sounds simple, right? But trust me, as soon as things start getting busy, this whole setup becomes a total recipe for disaster.
Yeah, this is what engineers call a tightly coupled system. A good way to think about it is like a car, where the engine is literally welded to the wheels. What happens if you need to fix the engine? You gotta take the whole car apart. It's just super inefficient and honestly pretty risky.
So the obvious solution, right? You separate them. You put the brain, that's your code, on its own servers and the memory, the database, on another. Now this is a huge leap forward for scalability. But, and there's always a but, in solving that one big problem, we've just created a brand new one. And that new problem is latency. See, now every single time your code needs a piece of data, it has to go on a trip across a network to another machine. And that trip takes time. We might be talking about just a few milliseconds, but believe me, those milliseconds add up fast. That delay, that's latency. And it's the mortal enemy of a good user experience.
So, here's the big question. How do we get the best of both worlds? How do we build a system that can scale up, but is also crazy fast? Well, this is where our hero finally enters the scene, caching.
The idea is actually super simple, but so powerful. Think about it like this. Instead of having to drive all the way to the library every single time you need to look up a fact, what if you just kept a couple of essential books right there on your desk? Caching is basically that. It's the digital version of your desk library. All right, so caching isn't just one thing. It's actually got a bunch of different layers. To really see it in action, let's go on a little journey. We're going to follow a single request, say from your browser, and see all the sneaky little spots where caching does its thing. So the first place your request looks is right inside your own browser. If the data isn't there, it checks something called a Content Delivery Network, or CDN, which is probably super close to you. And only if both of those come up empty, only then does it make the long trip to the actual application server. The main database? Oh, that's the absolute last resort. Okay, so stop number one, your web browser. It's smart. It saves all the stuff that doesn't change much, like logos, images, the basic code that makes up the page. And that's exactly why when you visit a website for the second time, it almost always feels way faster than the first. All right, next up, the CDN, or Content Delivery Network. And let me tell you, this thing is a total game changer. Instead of your request having to travel all the way across the ocean to get, say, a video file, the CDN has a copy of that video sitting on a server that might be just a few miles away. The speed difference is it's huge, absolutely enormous. And then, finally, we get to the application server itself. And guess what? Even it keeps its own little stash of data. A super fast, local cache of the stuff it needs all the time. This is perfect for data that gets requested over and over, like maybe your user profile or the details for a really popular product. So caching sounds pretty perfect, right? Like a magic bullet for speed. But it's not quite that simple. There are two really big fundamental problems with caching that every single engineer has to deal with. Okay, problem number one, a cache is small. It has to be fast, which means it can't hold everything. And problem number two, and this is the really tricky one, the cache is just a copy. It's not the original source of truth. So what happens if the original data changes? Let's say a price gets updated in the main database. Well, now the copy in your cache is wrong. It's out of date. And that's what we call stale data. This all leads to two critical questions that we absolutely have to answer. First, how do we stop our cache data from getting stale and inconsistent? And second, what on earth do we do when the cache gets full? Let's tackle these one at a time.
All right, first things first, keeping that cache fresh. This whole process of updating or, just kicking out old data from the cache, it's got a fancy name, cache invalidation. And luckily, there are some pretty clever ways to handle it. So one really popular strategy is called write-through. The idea is simple. Every time you update a piece of data, you write it to the cache and the database at pretty much the exact same time. Now, this makes writing a little bit slower, sure, but the huge benefit is that you can guarantee your cache is never out of sync. It's always fresh. Then you've got the opposite approach, which is called write back. This one's a little different. It's kind of like writing something down on a sticky note, telling everyone, yep, it's done, and then planning to file the official paperwork later. It's incredibly fast, but you see the risk, right? If you lose that sticky note before you file it, that update is gone forever.
Okay, so that's problem one. Now for our second big challenge. The cache is small, remember. Think of it like a closet in a tiny apartment. It's gonna get full. So when you need to put something new in there, how do you decide what gets kicked out?
Well, that decision is handled by something called an eviction policy. And by far the most common one is least recently used, or LRU for short. The logic is just common sense, really. If you've got a shirt buried in the back of your closet that you haven't touched in a year, it's probably safe to get rid of it to make space for something new. Same idea.
So let's just do a quick recap of this whole journey. We started with a really simple but flawed system. We scaled it up by separating things, but that created latency. So we brought in our hero, caching, and used its different layers to make things fast again. And we learned that it's this constant balancing act, right? A trade-off between speed, size, and making sure all your data is consistent. Caching is literally everywhere. It's what makes your newsfeed feel instant. It's what powers your online shopping cart. It is truly the unsung hero of the modern internet. So the next time you're browsing and a page just poof appears instantly, you'll know what's going on behind the scenes. It's this incredible, complex dance of data happening all over the world just for you in the blink of an eye.